Hello and welcome to another video. In this video we're going to be working on minimum distance to type a word using 2 fingers. And let's start the clock here. So you have a keyboard layout, XY plane, uppercase, K, A is at 0, 0, B is at 0, 1, P, okay, sure. String word, determine minimum total distance, type the string. Distance is this, okay. Initial positions of your fingers are considered free. Okay. And then cake. Okay, so you start at the C and the A, and then you move on, whatever. Cool. Happy. Okay. Alright. And that's pretty straightforward. So one thing to note here is actually, you might think that like you just want to start with your first two fingers on the first 2 letters. That's not necessarily the case. Like imagine we had a word like ABX. So in that case, you'd actually want to start with the first finger should be on the first letter for sure, but then the second finger shouldn't necessarily be on the second letter. It can be anywhere. So like for ABX, for example, you actually want the first finger to start at the A and then the second finger to start at the X. So yeah, I mean, we can honestly just like loop through every iteration and just every starting position is fine too. Yeah, that's fine. And then just like try everything because this is like pretty small constraints. So we can just call I think this is just literally DP, like straightforward DP. So a couple things here. I guess we need to know like the location of the letter. So let's see. So I guess maybe we can make a location function or something. Yeah. So we can make it like up here. All right. So basically, like, I think it's just gonna be, we need to know the ASCII value minus A. I'd like to know where we start. So like, word letter. So this will give us like the coordinate, like in 1D. So for example, here this would be like 5 or something, and then the row is going to be a lock divided by, what is it, like 6? And the column will be the lock mod 6 turn no call. All right, let's give this a try real quick just to make sure. Of A or something, and then let's try a couple A. Let's try like V, would be good enough. Okay, V 33. Yeah, okay. I mean, we could have hard coded dictionary as well, but okay. Yeah, and then from there, just DP, right? So basically, our choice is just take one finger, like the first finger wherever you're at, go to the letter, or the second finger. Yeah. So, okay. Let's think about constraints really quick, but I think it's fine. Like our row and our column is like 5, 5. Our second finger row column is 5, 5, and then we have, yeah, it's like nothing. Okay. Oh, we need to also know the index on the word, so it's like 5, 5, 5, 5, or whatever. How long is the word? Small. Okay, fine. So this should be fine. All right. So we need to know index. We need to know like, we'll call this x1, x2 for like row 1, c1, row 2, c2. So this is like finger 1, finger 2. All right. So if I equals length word, I return 0. So now we have a choice of going with one or the other. So we can say first hand moves, and then we can say this equals get location, or I guess we just need this anyway. Get location of whatever the letter is. Word I. Right. Okay, so first hand moves, result. Absolute value of new row minus row 1 plus absolute value of new column minus column 1 plus dp. Okay, so this one's the first hand move, so this will be new row, new column. Second one's the same. Second hand moves. Literally the same. Yeah, hopefully we don't time out. That is kind of, I did start noticing for these harder problems, you do actually time out sometimes, and you have to do bottom up and into pain. So maybe I should transition to just do bottom up as a default. I'll think about that. I mean, but this is only the case for like the really hard problems for anything like on interviews or whatever. And on interviews, you don't get a TLE, so it doesn't really matter. It's the same time complexity. So, okay, so this will be this way. This is the same. All right. Yeah. Okay. Oh yeah. Cool. Then we just do the min of all of them. Ideally, we do probably want to actually reset the cache every time. Is that costly? No. Well, actually, let's see. So this is 300. Actually, maybe it's a little costly. Well, do we need to reset the cache? I don't think so. No, we don't. Yeah, we definitely don't. Okay. So, equals. Yeah, I mean, we'll just try every square. Optimal is going to be, you are going to start at some letter, but that's a lot. That's even more use cases to start at. Like, imagine your words like A, B, A, B, A, B, A, B, A, B, A, B, and then like an X or something. The second finger will still start on the X. So instead, we'll just go through the grid and try it that way. Yeah, so this will be like 25 by 25. I mean, this is getting kind of big, actually. We'll see if we time out. Okay. 4 5. Wait, 1 through 4. Yeah. 6. So we just have to check if we're not on this out of bounds thing. I guess we'll do that separately. We'll just do 4 rows and then, yeah, so min. Okay. No, actually for all of these, yeah, this shouldn't time out at all because the DP is still going to be the same. It's just going to be, like for all of these, DP will be O of 1, so we shouldn't time out. There's no way. I mean, at least I think. So, 0. Okay. Oh, we have to do this for both, right? Yeah, we have to do this for both, so let's redo it. So, for row in range 6, for row 2, we'll do 5 actually. That's fine. And we just have to make sure we don't have the invalid ones. Yeah. Okay, so for row 2, or yeah, 2 in range 5, for a call 2 in range 6. So we have to check for invalid. So if, I guess we can check for invalid here. So if row equals 4 and column is greater or greater than 1, we'll break. Same here. If row 2 is 4, 2, break. Okay. Yeah. And then we'll just do res equals max res, and then this is going to be dp 0 and then the locations, right? So row call 2 call 2. Maybe a little harder than I thought. Like there's decent amounts of stuff. Hopefully we'd crap. Res. Let's see. I mean, we still didn't necessarily get the right answer. Right? So, yeah, null. Interesting. If I equals length word. How do we get null? Oh, we want the min. Yeah. That's what we got. No. 6-3. Interesting. So we got the wrong thing. Did it do the distance wrong or something? X. So column minus C1. No. Oh yeah, this should be 2. Wait. First hand move. Okay, yeah. Okay, yeah. Awesome. Okay, yeah, I wasn't sure if I get it right. Oh, so yeah, something I like to do afterwards is throw the GPT and clean anything up, stay top down, and see if there's anything better. We can do a better model. Let's do like mini. I don't know. I thought there was like a 1 here. I don't know which one's better. Oh, there's 4.5, right? Yeah, I don't know. I don't have that either. 4.5. Let's try it again. Okay. No typo, self, typo, interesting. Added at cache, import. Oh, okay, whatever, it's fine. Doesn't matter. Oh, and then it got stuck. What am I paying you for? Okay, well, whatever. Fine. Yeah. Yeah, we'll see how we do in these harder problems. If I do DP and we get TLE a lot, for the easier ones, you never get it. For these harder ones, if we get it a lot, I might consider doing bottom up. We'll see. Okay. And it's kind of dumb if you get like a TLE, like I tried this before, you get a TLE in Python and then you do same top down like C++, like I literally just GPT convert my code in C++ and C++ passes. That means test cases. It's kind of annoying, but whatever. All right, so I guess let's talk about the time and space and all that for this guy. So essentially, so you can have for each one of these 26, like this is 26, this is 26. So, and the index will be length of word. So we'll call that n, and this will be like 26. This is just two decisions we can make, so that's nothing. Get word is constant time also. And then this part. So it's important to know that like these aren't multiplied, because for each one of these we're gonna call DP, but we're still reusing the same outputs. So this is gonna be just like this. So looking back, yeah, it's pretty easy for it to pass, because like 300, 30, 30, that's like 10 to the 5th. This is nothing. So, yeah. And then the space is just going to depend on that. Okay. Yeah, I guess, I mean, this will just copy mine, right? Because it's literally just, if I write it, yeah. Okay, thank you for that. Okay, yeah. So I guess more complicated DP problem, maybe there's a little bit more than I thought, but not too bad. I mean, it's pretty straightforward. You just like figure out where your starting locations. You don't even need this. You can just hard code a dictionary with all the locations if you want to. But yeah, I mean, this is just basically how to get coordinates in O1 instead of hard coding the whole thing. And then yeah, I could obviously like actually use variable names instead of random numbers, but whatever. Yeah, so that's gonna do it for this one, and I'll see you in the next one. Thanks for watching.